In this lesson, you'll learn exactly how to track down a sensor signal voltage that is stuck low, prove whether it's a wiring, sensor, or reference problem, and verify scan data before replacing parts. A sensor signal stuck low might look like a failed sensor, but other causes, like a short to ground, failed 5V reference, or open in the circuit, can create the same scan data. Diagnosing correctly is critical to fix the root problem. Typical position, pressure, or temperature sensors use 3 wires: a 5V reference from the ECU, a sensor ground, and the signal back to the module. The signal changes based on sensor values, but only if the reference and ground are solid and the circuit is intact. The ECU monitors the signal voltage against predefined thresholds. If the input voltage drops below a certain limit, it's considered circuit low and may trigger a fault code. But the module doesn't know if this is caused by the sensor, wiring, or reference. It only knows the voltage is out of range. Scan data shows the ECU's interpretation of the signal, not always the physical voltage at the sensor. Compare live data to a direct voltage measurement at the sensor or ECU pin to catch wiring faults, bad grounds, or misleading readings from module interpretation. For most sensors, a typical signal voltage ranges from near 0.5 volt to 4.5 volt. A stuck low reading, such as 0.1 volt or 0, signals a problem. Measure voltage at different points in the circuit to see where it's lost and compare to normal behavior for the system. Many ECUs compare one sensor's value to others, like comparing throttle and pedal position or coolant and intake air temperature. If one sensor is stuck low while related readings are normal, the module may flag a plausibility code or data mismatch to help rule out real system context. Don't immediately replace the sensor when you see a low signal code. Many mechanics skip voltage, ground, and reference checks, leading to repeated failures or unnecessary parts. Always confirm each leg of the circuit before making a repair decision. Start by confirming the DTC and observing scan data. Next, use a multimeter or scope to check signal, reference, and ground at the sensor. Then at the ECU. Compare all values. If voltage returns to normal when unplugged, a shorted sensor is likely. If not, trace the wiring toward the module. A sensor signal stuck low usually means more than just a failed part. Always prove the 5V reference, sensor ground, and integrity of the signal circuit. Compare scan data to real measurements, check plausibility, and use consistent logic before any repair. You've just learned how to rationally diagnose a sensor signal voltage stuck low, avoid costly mistakes, and use data and circuit logic to get the right fix the first time.